With all this today, since we usually would go over the test now if I hadn't let you take it home, so should get through stuff pretty quickly today. Figure out what this is, start copying down what you need to on your notes. Start dealing with angles this chapter. We're going to start getting into a little, I shouldn't say harder stuff. Some of that stuff the first chapter was not the easiest, but figure it out, Damon. Damon, did you figure it out? Where you're at? Figure it out. I know I screwed up on this one because I put the title on every page instead of just on the front page. I forgot to click the little box that said not to do that. Again, if I don't have your test, get it into me as quickly as possible because each day it's going to count all points. And here in a couple days, I'll put it in the grade book and there'll be a 0. And guess what happens to your grade when I put a 0 in for a test? A whole bunch of my other class figured that out today. The grades went from like 80 to 13 or something.
Yeah, it's a little
Does
bit of a jump.
does the review packet count as a grade as well?
Yeah, so
Correct
make
or
sure you,
complete it?
all right, make sure you get it into me. Also, make sure you do those 2 things online.
The
That's
things from last class that we went over.
Yeah, we went over one of them and did, and then the other one was
I gotta remember to do that in your packet.
the dynamic
Joe,
module, whatever it was. It's called dynamic, or module 1, dynamic practice or something like that.
And I really did it in class, and I didn't have to do it at home by myself.
All I do, I'll just do it on the bus then.
Yeah, we did one of them in class, the other one.
I did
myself
the other class when you weren't here.
When I
Yeah, I did
was-
both
we were
first
supposed
class
to.
too.
Yeah.
Why do you think I'm kidding?
Yeah, I know. Our bus is back too.
So on this array is a part of a line consisting of a point on the line called the endpoint. I'm not sure why it's called the endpoint. It should actually be the starting point because that's where the array starts. Together with all collinear points on one side of the endpoint. What's collinear mean again?
On the same line.
On the same line. Name me a ray in this picture.
TS.
Could you pick any letters?
Yes.
Yeah. All right. So if we say TS, what's that telling us?
No, it starts at T.
And it goes out through.
S.
Now with this ray, what's another way to name that ray? That's the exact same ray.
TH.
TH. Because look what happens. If I start at T and I go out through S, then I start at T and I go out through H. Is there anything different there? Now you got to be careful. Would ray ST be the same ray?
No.
Why not?
Because S doesn't go through T if you're going the same direction.
Which ray is this? Where do I start at?
S.
Starting at S and you're going that direction. All right? So you got to be careful with rays. Rays, it's called the endpoint. Always has to come first. It should be actually be the starting point. And you're just telling a direction. What if I gave you this ray? Ray NT, what's another way to name that ray? NH would work. Ray NH, what's another way? NS. All right, so all different ways to name a ray. Opposite rays, we talked a little bit first in chapter 1 about opposite rays. You guys picked TS, so let's use that one. ray TS is one of our rays, and so if I'm here and I'm going out that direction, my slide doesn't change on me. I'm going out that direction. What's a ray that would be exactly opposite of that ray?
TN.
First of all, where's it going to have to start?
T.
At T. It's going to start the same point that I started my ray at. And it's going to go in the opposite direction. Whenever you have two opposite rays, they're always going to form a straight angle. Don't say a straight line, because all lines are straight. Okay? It's a straight angle, and the measure of that straight angle is always 180 degrees. Could we pick two different rays there that were opposite rays? Yeah, there's a whole bunch of them we could have picked. Opposite rays go in opposite, just have same starting point or same end point, whatever you want to call it, and they go in opposite directions. How about these two rays? If I draw that ray, and I draw this ray, are they opposite rays? No. Those actually form an angle, and that's what we're going to talk about next. They form an angle. They form an angle other than a straight angle. So an angle is a pair of rays with a common endpoint. And again, I hate calling it the endpoint. It's actually the starting point of the rays, but you guys understand that, right? Gwen, you understand that? Just because some stupid math person called it an endpoint at some point, it's actually the starting point of the thing, not where it ends. A lot of this you should already know. The first couple things maybe not, but classifying angles I'm sure you've done at some point in the past. You probably had some teacher that was more creative than Ebersole, and they, oh, an acute angle. Remember those are the small little acute ones. Did you ever have that, Joseph? Had that teacher like that?
I hated those.
And then everybody, oh, it's a cute angle. Oh, because it's a little bitty angle. Oh, so cute. And obtuse, they probably mentioned Ebersole.
No, they just say it in a really good voice.
Big fat angles.
Was he just crying? Or
It's called. Now the one thing I will say, usually I do this, I didn't feel like doing it today. Usually I have you write in the definitions before I put them up there and explain to you where you're wrong at. Because if I ask you the definition of an acute angle, what would you tell me?
Smaller than 90 degrees.
Smaller than 90 degrees. That's wrong. All right, look at my definition. What's different?
Measure between 0 and 90.
Between 0 and 90. Are there other numbers that are smaller than 0?
Yes.
Yeah.
Yes. And there are other angles that are less than 0 degrees. An acute angle is only the angles from 0 or between 0 and 90 degrees. Is 0 included in that? No. Is 90 included in it?
No.
No. Because 90, if it's got a measure of 90 degrees, it's a what?
Obtuse.
Right.
It's a right angle.
Oh.
And then an obtuse angle, normally everybody, when I ask them what's an obtuse angle, what do they tell me?
Bigger than 90.
Bigger than 90, because that's what you learned. And that's not the case. It's actually between 90 and 180, because it doesn't include 90 and it doesn't include 180. Straight angle, we already talked about, it's 180. And where degrees, anytime you're measuring angle, it's always in degrees. The reason, if I'm standing here and I turn, how much did I just turn?
180
180 degrees. I turned half a circle, which is 180, and that's where measuring an angle comes from. It's how much of a turn, if I'm standing here like this, or my arms are the sides of the angle, how much of a turn is my arm making, all right? That's where the measurement comes from. An angle is a pair of rays with a common endpoint. So it's just going to be two rays, and they share that endpoint. Does anybody know what that endpoint is called? You should know it because hopefully you wrote it down.
Vertex.
That's the vertex, all right? So they share that point, and it's called the vertex. This is a ray, that's a ray. Those are the two sides of the angle. Some of the stuff that's going to be on this next slide. If I have any idea what's this part called in the or for the angle?
Interior.
Interior. What's this part out here called?
Exterior.
Exterior. So you have the interior of an angle, you have the exterior of an angle. Something's on the inside of the angle or something's on the outside of the angle. Sometimes we deal with that. You guys don't have this doubled up on yours, do you?
No, I don't. We don't have classifying angles.
I must
It
have-
goes straight to angles.
There you go.
I must have forgot to delete something when I was adding stuff in.
Miss Barnes always talked about how loud you were.
You
We
weren't
couldn't hear
loud.
you.
The only thing that I ever heard was Kahoot.
I remember that. Okay, he
Oh,
it
it
just
just
moved
so
back.
your attention.
We never played Kahoot either.
It was last year, I remember.
I never have played, never in any of my classes.
It was
Well,
probably
it was some
chemistry
class I
Was
remember.
that
playing
good?
Kahoot.
Might have been Mr. Slang across the hallway.
Oh.
Wasn't this class?
Yeah.
No, what's your class? 'Cause I heard you yelling about it. Him saying Kahoot.
Never ever played it with any of my classes ever. I don't have any idea how to do it. I don't have any want to learn how to do it.
Then you were probably complaining about something. I remember it's one day you yelled Kahoot and we were.
I probably yelled something. I don't, it probably wasn't Kahoot. That's probably what you heard, but I probably was just yelling to mess with somebody. Like when Joseph starts to doze off and
Wait, where's Colton?
I wish I was able to fall
He was
asleep
here
at
for
school.
like
I'm not.
3 days in a row.
He's here today as well. He was here this morning. Yeah, he's here this morning.
And Jerry left.
Wait, he's not here?
Never fall asleep.
And Joey's not here.
Why not?
Andrew's not here.
I don't know.
Dude, if Window ever woke me up, I would slap him so hard.
so, on this, interior, exterior, you gotta be able to find the vertex of an angle every time. Vertex here is P. You gotta know where the vertex of the angle is. It's where the two rays come together. Alright, so you have to be able to pick that out. Very, very important. Sides of this angle, ray PK, ray PG, and the vertex is always point P for this angle. Very important to be able to pick that out. When we go to name an angle, sort of difficult, and this is, Damon's gonna have to pay close attention, because if you pick up on it right now, it'll be easy. If you don't pick up on it right now, it's gonna mess you up all year long. So naming an angle, before you write any of this down. When we're naming an angle, this is the symbol for an angle. Alright, it's just an angle. It goes out in front of the letters instead of on top. All the other symbols that we've dealt with so far went on top of the letters. It goes out in front. 3 different ways to name an angle. you guys had trouble with naming a plane because there was 2 different ways. Now there's 3 different ways. Does that mean it's going to be double the trouble? I hope not. All right, 3 different ways to name an angle. One way is with 3 letters. That's the way I prefer. All right, because if you name it with 3 letters, you can't screw it up. Well, I shouldn't say that.
You could.
You could. I mean, if it's this angle up here and Damon puts down angle ABC and there's no ABs or Cs in the picture anywhere, then yeah, that's messing it up. But with 3 letters, you're just going around the angle. So you're starting at one side and going through the angle. All right? So this angle, I would name, what's that letter?
K, P, G, O, O.
That's either way. All right? So we could name this angle, that symbol, K, P, R. It's that simple. It's like you're walking around the angle. Where's people going to, students going to mess that up at? What are they going to do?
PKG.
They're going to start here and go out one of the other directions. Got to start at one side and go around the angle. Another way you can name it, this way I do not like at all, the angle symbol and 1 letter. And that's fine if there's only 1 angle in the picture. How many angles do you see here in this picture? 1. So this time it'd be okay. And it's just the short, lazy way to do it. We could name it just angle and then just the vertex, angle P. If that's the only picture or the only angle in the picture. The third way, and by the time we get down to the end of the year, this is probably the only way that we'll use because we'll have so many angles in the picture, it's too hard to name it with 3 letters. If they put a number on the interior close to the vertex, then we can name it with just that number. We still got to use the symbol, so it'd just be angle 1. 3 different ways to name it. Go ahead and copy down whatever you're missing there. Make sure you're using the symbol on all of them. Again, if you just write down, if you just write this down, oops, I don't have any idea what you're writing. I don't have any idea what that is. I don't know if it's a plane, I don't know if it's an angle, I don't know if it's 3 separate points. So you've got to have the symbol on there out in front whenever you're naming an angle. This one, usually I do that and say try not to use that one if you don't have to. There's just one angle in the picture, it'll work, but if you don't have to use that one, use one of the other 2. That way you can't mess it up. Just on your notes there on the bottom. I'm going to stop this recording for a second. So give me an angle using a number.
Angle 5.
Number 1.
Angle 5. Make sure an angle symbol looks like this. Don't get it confused with what?
Greater than.
The alligator mouth, right? So whenever I make my angle symbol and whenever I make my greater than less than symbols, I make it so you can tell that there's a difference in them. So angle 5, give me another angle that we can name with a number.
Angle 1.
Angle 1,
8.
angle 7.
8.
Where's angle 1?
The what?
What,
Wrong side of
if
angle
I was
A.
gonna walk around angle 1,
ABC.
how would I
Or
walk?
AF.
A to B, then to, alright, so A to B to F. Name me, an angle using 3 letters.
AB.
Angle ABF.
BDC.
Angle BDC, everybody agree with that?
Yeah.
GDH.
GDH.
GDH, is that what you said?
Yeah.
GDH. Now, on this angle, symbol out front, GDH. Name me the vertex of that angle.
D.
Gotta be the middle letter. The vertex always has to be the middle letter when you're naming it with 3. So that point right there is where that angle, or where those 2 rays come together. Name me the 2 rays that make up angle GDH.
DH and then DG.
DH, notice, starts at D and it goes out through H. The other one, so it starts at D, goes out through H that direction, going that way. And the other one starts at D and it goes out through G, going that direction. Name me a straight angle in this picture.
EDC.
EDC.
BD.
EDC. Does everybody agree that that's a straight angle?
Yeah. BDG.
BDG, would that be a straight angle? What do we know about about a straight angle? We're not gonna learn this today, but
Vertical or horizontal?
it's, how many degrees? 180 degrees. What can you tell me about these 2 angles then?
Congruent.
Now, they could be 90. Do they have to be congruent? Not necessarily.
They just have to move that.
They have to add up to equal 180, and that's something that we're gonna learn next time. Are there a whole bunch of other angles in this picture that we could have
Yes.
named? Any picture, or any angles in this picture you could name with just 1 letter? If I pick angle D, ignore that. Angle D,
It's the vertex.
that's the vertex. Which angle is angle D?
GDH, EDG.
Do we know which one is angle D?
There is one now.
And that's why we don't name it with just that 1 letter, because whoever looks at it next, are they gonna know which angle we're dealing with? That's why I don't like naming it with 1 letter, because it could be any of those angles. So we don't know which one it is.
I was gonna say B, but that doesn't work either for boot.
No, because if we pick B right there, could it be this angle? Could it be this angle?
Yep.
Could it be this angle? Could it be this angle?
Sure.
Could it be that angle and that angle, those 2 angles put together? Yeah. All right, measuring angles. Fill in what you need to fill in on this. Then we're gonna do something else here in a second. When you're measuring angles, angles are always measured in degrees. Congruent angles are angles with the same measure. Just like with segments, congruent angles are 2 angles that have the same measure. What was a segment bisector? What does segment bisector do to a segment? Split it at the midpoint. Split it into 2 equal parts, right? What do you think an angle bisector does?
Split the angle into 2 equal parts.
Splits the angle into 2 equal parts. So, if I tell you that this is the angle bisector, if this right here is the angle bisector, what 2 angles can we write in here that have to be congruent?
LBA.
Does everybody agree with that? So if I just write this down, LBA, is that going to be correct?
No, you have to put the symbol.
Make sure you put the symbol, all right? And make sure you write well enough that you can tell the angle symbol and the L apart. So that's this angle, LBA. What's the other angle?
ABC.
Everybody agree with that?
No.
Now, in the picture, when we want to say they were congruent, when we were doing segments, if we wanted to say that these two segments were congruent, we used the little tick marks on it. Now we do the little arcs, or part half a circle or whatever. So it looks something like that. Make sure you put that on your paper so that you know. What's that tell me about these two angles?
They're congruent.
They're congruent, they're equal. Sometimes you'll stick a little extra on there. Whatever it is, just to show that, hey, this angle is the same as this angle. Maybe when Maya's doing it, she likes to be all creative and stuff. So maybe she does something like this, puts that on there, and then puts a little curlicue or something to make it look all nice and cute or something. As long as the two angles are marked the same, we know that they're congruent. What angle, for these bottom two blanks, what angle is being bisected?
BA.
What angle is being bisected?
Oh, LBZ.
Everybody see that? LBZ. This whole angle, going around it that way, is the angle that's being bisected. What's doing the bisecting?
B.
The BA, right?
And that's what it is. Anytime an angle is being bisected, can it just be this point B?
No.
Can it just be that point A? It's got to be the whole ray. So ray, where's the ray start at? B, and where does it go through? So ray BA is the angle bisector of angle LBZ. What's another way to name angle LBZ? Could have named it backwards, ZBL. What's another way to name angle LBA? ABL. What's another way to name angle ABZ?
The CB.
I'm gonna have to move you.
No,
I think
it's not my doing.
I'm gonna move you right to here so that.
Hey, I was sitting here very quiet and calm until Joe Daddy started
Wow.
stabbing her in the ear with this.
Stabbing you in the ear.
Yep, I was ear raped. Let me rape your ear.
Quit.
Oh,
Get your protractors out so you can follow along with this. As I get it turned up there.
Alright, leave those in the trash can. Thanks.
That looks like that thing with this really googly next to you.
Unmute it. You want to unmute it?
180 to 0 on the inner line. Using a protractor. The protractor has two scales that run from 0 to 180 on the outer line and 180 to 0 on the inner line. To measure an angle, line
Do me a favor,
using a protractor.
somebody go up and shut the lights out. It's gonna be hard to see that.
First,
It's
turn
both.
the lights off.
I'm pressing it.
Oh my god, do you know?
Press them both of them.
I am.
There you go.
Whoa!
I didn't press one at a time.
Okay,
It's
The protractor has two scales that run from 0 to 180 on the outer line and 180 to 0 on the inner line. To measure an angle, line up the center of the protractor on the vertex of the angle. Make sure you align one side of the angle with the 0. Since the angle is aligned with the 0 on the inner scale, look to see where the angle intersects this scale. It intersects at the number 50, so the angle measures 50 degrees. If the angle opens the other way, you will measure the angle using the outer scale. Since the angle is aligned with the 0 on the outer scale, look to see where the angle intersects this scale. It intersects at the number 70, so the angle measures 70 degrees. You can also...
On those two, how can you tell which one you're going to use?
Look,
Left or right? Choice.
look what way the
Do
angle.
you really want to know if you're starting on the left or right? Is that gonna, that's probably gonna confuse somebody, isn't it? What kind of angles were both those two angles that he was just measuring?
Acute.
They were both acute angles. What do we know about acute angles?
They're always under.
They're
It's
always
made.
less than 90, smaller than 90, right? So when we get out there to our number and it says 70 or 110, which one do you know to use?
70.
The 70, because it's an acute angle. If it was more than 90, if it was an obtuse angle, then we use the one that is the bigger number. And what's going to happen when you got your protractor upside down? Does that mean it's messed up, you can't use it?
No.
No, it's still the same thing, it's just the numbers are upside down.
Yes.
Use the protractor to draw an angle. Start by using the bottom of your protractor as a straight edge to draw the base of your angle. Mark the angle vertex with a dark point. Now align that point with the center of the protractor, making sure that the line you drew lines up with the 0 degree mark. Without moving the protractor, draw a point at the desired measurement of your angle. Finish up by using the straight edge of your protractor to draw the remaining ray from the vertex on your baseline through the measured point.
It says pencil breaks.
Everybody think they can do that?
Yeah.
Sure.
Nothing hard about it.
I mean,
We'll measure some angles coming up, not today, but soon.
Stop it.
it's so
No.
cold, I'm crying.
Says you.
Reason, don't cry.
Why
It's
you really
freezing in
yell
here, can't help
clear?
it. I need to-
I thought I was lower. I thought.
Fill in what you need to fill in on this one. Now we're getting to a little more difficult stuff.
Jason. It's freezing in here.
Yeah, I turned it up this morning, but I don't know, it's not doing any good.
Now that the AC's actually in, it's cold.
It's cold outside.
I think they made it that way just since everybody complains so much.
Look, I'd rather be hot than cold.
No.
No.
No, I'd rather be cold than hot.
Yeah, I'd rather be freezing.
I'd rather not sweat
I'd
and
rather be
smell.
sweating.
I do that anyways.
What's the word adjacent mean?
Like,
Two angles that share a side.
Don't tell me what adjacent angles are. What's the word adjacent mean?
like next to it?
Next to it.
Neighbors.
Side to
Neighbors,
side.
exactly. They right next to it. Whose room is adjacent to my room?
Yours.
Mrs. Barnes's room. All right. We share a what?
Wall.
A wall. Just like adjacent angles. Adjacent angles share a side and a vertex. All right. They share a side and a vertex. Just like my room and her room shares that wall. Linear pair. What do you think it means? First of all, what's pair?
Two.
Two. Not three, not four, not one, two. So it's a pair, and what do you think linear means? Line. So it's a pair of angles that together make a line, or a straight angle. Vertical angles.
Up and down.
Vertical usually, like vertical means going up and down, doesn't it?
Yeah.
Horizontal means going side to side. But that's not what this vertical means. Vertical angles, if I draw this, two non-adjacent angles formed by two intersecting lines. We did some of this in the first chapter. You might want to write it down there on your paper as I draw it. What are we, if we're going to, this right here that they're describing to us, if we're going to draw it, what are we going to draw?
An X type.
So I got one line, and what else am I going to draw?
X.
Another line
Intersecting.
intersecting. How many angles do I have there?
Four.
Watch, I'm going to number them. 1, 2, 3, 4. Again, this might be a good thing to have on your paper there. We want vertical angles. Two non-adjacent angles. What do you think? If adjacent means next to each other, what's non-adjacent mean?
Not next to each other.
Not next to each other, like across from each other, right? So give me two angles in that picture that are across from each other.
1 and 2 and 4.
1 and 3, I heard. So angle 1 and angle 3. Those are vertical angles. Give me another pair of vertical angles.
2 and 4.
Angle 2 and angle 4. Oh, stupid thing. Those are vertical angles, and those angles, no matter what, no matter how Allie draws her picture, those angles will always be congruent. No matter how you make your two lines intersect, those pairs of angles are always the same as each other. So if I told you angle 1 here was 62 degrees, what do you know?
3 is 62 degrees.
Angle 3 has to be 62 degrees. Scoot over here. What?
I got the degree of 2.
We're going to talk about that here in a second. This part up here says it's a linear pair. Can anybody name me two angles in this picture to be a linear pair?
1 and 2.
1 and 2. So angle 1 and angle 2 are a linear pair. We said that together they have to make a
180 straight.
straight angle, which is 180 degrees. You might want to write that in your notes right there too, in case you forget it. Well, if angle 1 and 2 add up to 180, can we find angle 2 right there?
Yes.
How much is it?
118.
If angle 2 is 118,
4 is 180.
4's got to be 118 also. So I told you that one angle right there, and in that picture, you could find the other 3. And every time for the rest of the year that I give you a picture that looks like this, and I tell you one of the angles, you should be able to find all 3 of those other ones real easily. What's another pair of angles in this picture that are linear pairs?
2 and 3.
2 and 3, everybody agree with that? Give me another pair.
3 and 4.
3 and 4.
1 and 2.
4 and 1.
I don't have any more room, but 4 and 1, so on, so on. Our first theorem. We just proved our first theorem. Our first theorem, it's the shortest theorem in geometry. Vertical angles are congruent. Now, whenever you see me write this, you'll never ever see me write this out again because we'll use it thousands of times before the end of the year. This is the way I'll write it. I'll abbreviate vert. I'll use the symbol for angles, R, and then to make that shorter, use the symbol for congruent. Vertical angles are congruent. Week from now, if you don't know this, hold on, I gotta do this. Oh, how much I love all my students. Yeah, I recorded that. Vertical angles are congruent. Linear pairs, what do we know about a linear pair again? They add up to
180.
180, very good. Is this on your guys' paper or not? No, it's not on there?
No, there's not.
Doing name me a linear pair. Let's do that first. I'll tell you this, you can pick any angle you want, and it's got a linear pair in this picture. So somebody pick me an angle. Say it again. ABF. I'm sorry, Sam, I didn't hear what you said for sure, so I didn't.
You're fine.
That's why I didn't use it. Not that I like anybody else better than you, just I didn't hear what you said. So we got this angle, ABF. We want another angle that along with that angle makes a straight angle or is a linear pair with it.
ABC.
Does everybody agree with that? ABC. Those are a linear pair. Let's go back to angle ABF. Because I don't like that linear pair.
Okay. FB. Oh, sorry.
F, B, E. Do those two angles there together make a linear pair? Yeah, together they make a straight angle?
Yeah.
So what do we know about those two angles? Together they add up to how much?
180 degrees.
180 degrees. Let's name a pair a little tougher. Let's name a pair of vertical angles.
ABF.
Okay, so if we start with angle ABF, got to be real careful here.
CBE.
ABF is this angle. Everybody see that?
Yes.
Angle 4, is that vertical to it?
No.
Doesn't quite work, does it? What has to happen when you have vertical angles? This side of this angle has to be an opposite ray with the side of the other, or one of the sides of the other angle, and this one has to be an opposite ray. So in other words, if this is my side that I'm looking at, that's the one that's the opposite ray. This is my side, that's the one that's the opposite ray. So what angle is vertical to it? Angle C, B, E. So if I told you this, Fletcher, you watching this?
Yep.
I told you that angle's 60 degrees. I came over here and I told you angle 4 and angle 3 were congruent. First of all, what's that tell us about ray BD here? What's it do to the angle? Cuts it in half. What's that called in geometry? Started with a B. We just went over it a second ago. It bisects. So that ray bisects that angle. How much is angle 4?
30.
How much is angle 3?
30.
Because these two together should add up to be how much?
60.
How much is this angle right here? 120 degrees. Because these two together, this one and this one, should add up to 180. How much is this angle up here? 120. So on, so on, so on. So given that one number, we could find all that other stuff. This is on your paper, right?
Yeah.
Take a second, try to write in those, and then we'll look at them.
Oh, whoa. Just every single one of them, just right in front of me now.
Yep. Been there all year long. That's why it'll be so hilarious when we take a vocab test and people miss what they are, and they're hanging on the wall somewhere.
Well, if you don't move the seats and I'm here for the rest of the year, then I'm pretty good.
Now that you said
I
that.
feel like you're gonna move me now.
So hopefully Fletcher's got little brains. We go to take a vocabulary test. He knows that there's a pencil sharpener on my desk, and there's a pencil sharpener up here, there's a pencil sharpener over there. He goes, where's that one poster at? Oh, it's up there. So he gets up and comes up here as he's walking towards the pencil sharpener, and he just sort of looks at it to make sure that he knows what it says, and sharpens his pencil and comes, sits back down.
It's really won't be obvious.
Pair of adjacent angles, let's start there. Adjacent again means what? They share a side, they in a vertex, neighbors, right next to each other. Pick me an angle. Let's name these first ones. Let's go the easy route and let's name them with the numbers.
Angle 8.
It doesn't matter. You could have named them the other way. Angle 8. We pick angle 8. So that's right here. Give me an angle that's adjacent to that angle.
Angle 6.
9.
I heard 3 different answers. 2 of them were correct. 1 of them wasn't.
7 or 9.
Joseph. That'd be a better call.
Oh, I see.
So this one, angle 8, angle 9. They share a side.
Mm-hmm.
They share a vertex. Now, did you have to have that answer?
No.
No. Are there other answers that you could have put in there?
Mm-hmm.
Yeah, there's all kinds of them. Anybody want to check theirs to see if it's right? Or are y'all too chicken to be wrong?
Like exactly.
What if I just did this? Those are my adjacent angles, am I right?
No.
Oh, so I messed up.
If you were going to choose angle 1, you probably choose angle 2.
Angle 2 or angle what? 4. But my whole point was, I wasn't the chicken to be wrong. Ain't nothing wrong with being wrong. Nobody wants to tell me theirs to see if it's right or not.
I said 8 because it was like the easiest one. It was like the first thing I saw because I feel like it's a bigger angle.
We're trying to freeze.
All right, let's go to a linear pair then. Do we want to use 3 letters this time?
Yeah.
All right, so let's use 3 letters. Angle what? F, D, C. Gets hard after a while once I draw on these too much. F, D, C. Does everybody see that angle?
Yeah.
We want a linear pair with that angle. 2 different answers you could give me here.
GDC.
G, D, C. Together, those 2 angles make a line. Yep. What's the other angle you could have given me if we used FDC? E, D, F. Does everybody see that angle?
Yeah.
So you could have used that one and this one. Together they make that line. Can't hardly see my picture anymore.
That's okay.
Vertical angles. We using letters or numbers? Letters. Is there any angle in this picture you can name with 1 letter? Not a 1. So if you name any angle in this picture with 1 letter, you know it's wrong.
What about C?
Nothing. There's none in this picture that you can name with 1 letter. So either using 3 letters or the numbers. Vertical angles.
Angle ABD.
A, B, oops, not A, B. A, B, D, that angle?
Yeah.
Can't see it, hold on. Color, give me something else. A, B, D. Everybody see that angle?
Yeah.
First of all, it appears to be what kind of angle?
Obtuse.
Obtuse. Now, could it have been named angle ABG?
Yeah.
Yeah, D's right here. Does it matter which letter we put on that end?
No.
So we could put ABD, that's the exact same angle as ABG, same angle. We want the angle that's vertical to that.
FDC.
F, D, C, that one.
Oh, I mean FBC, my bad.
FBC. So F goes from F to B to C. Does everybody agree with that? So we did this angle. Is this angle the angle that's vertical to it?
Yes.
Yeah. What do we know about those 2 angles?
Better linear.
They're
No, not linear.
congruent to each other, right? Have the exact same measure. Now, I probably would have went like the easy way, and I probably would have picked something like angle 6. Which angle's vertical to angle 6?
A.
Just to make my life easier. So, adjacent angles. When they tell you a pair of angles is adjacent, mathematically or numerically, what do you know about them?
Neighbors.
They're neighbors. Is that mathematical?
No.
What do you know about them? Are they the same, or do they add up to 180? Do they
Add up to 180.
add up to 180?
They make a line.
Do they have to make a line? Do we know anything about them when they're adjacent? No, only that they're neighbors. Does this really help us a whole lot then? Adjacent angles, I almost wish that they'd never even introduce adjacent angles. Because it tells us nothing numerically. Doesn't tell us that they add up to anything, doesn't tell us that they're congruent to each other, nothing else. If they're a linear pair, we know what about them? They add up to 180. If they're vertical angles, what do we know about them?
Congruent.
They're congruent, they're exactly the same. Adjacent angles, my room and Mrs. Barnes's room, do we know that they're exactly the same as each other? No, they're adjacent, but that doesn't tell us that. Do we know that they add up to 180? No, that doesn't tell us that. Open up your books, page 71. Gwen, you ready for this? Because now everybody's going to have to answer questions. This is Allie's favorite time. Joseph, you'll have to be listening carefully because Allie doesn't talk loud enough for me to hear her. So you'll have to tell me what she says. Page 71, this is part of your homework. We've got about 19 minutes. Whatever we get done means what, Fletcher? Less homework. So I should probably waste some time, shouldn't I?
Yes, yes.
It's already recorded.
Just give me a second to
For what?
recook. I'm freezing, man. I can't even think straight. My nose is running. Everything.
all.
It's so cold.
This is the best I've felt in a week.
Number 1. So these pretty easy. Number 1. Name the vertex. Number 1. Name the vertex of angle 1. What's the vertex of angle 1? Go ahead. Point A. Everybody agree with that?
Yeah.
Yes.
Number 2. Name the sides of angle 4. Now, when we name the sides of angle 4, there should be how many of them? 2. And they should be what? The sides of an angle. What are they? What kind of shape?
Raised.
Raised. So I know I'm going to need the raised symbol on both of them. Look at angle 4. Be careful. What's one of the rays?
CA.
Everybody agree with that?
Yeah.
If this ray starts at C, what's the other ray got to start at?
C.
C also.
And CD.
CD. Everybody agree with those two? Number 3, what's another name for angle 3?
Angle ADC.
I don't like that one.
Okay.
And Lillian's not allowed to answer anymore. Can we name it angle D? Can we name it with one letter? Because there's more than one angle at that vertex,
You
right?
said you can't do ADC?
No. You can turn it around.
CDA.
CDA, would that work?
Yes.
Angle CDA. Making sure you're using your angle symbol. Number 4, what's another name for angle CAD? You guys got to start picking this out and make it easier. See, Sam picked up on it. Just turn it around and go backwards, right? What's another way that you could have named that angle? They gave you a number in there. Angle 1. Could have named it either one of those two. Everybody got that much so I can erase this? I was going to get up, but it's too comfortable.
Wait, wouldn't another name for CDA, there's like, 1 is also there, but wouldn't 3 be 1 also?
For CDA, it's 3. The last one was CAD. So that's the one that was angle 1. Number 5 is a little harder. Give me about 10 seconds or so to draw this picture. Somebody be ready to help me out. And we got to do this throughout the year so it doesn't take so long. Help me out and give me the letters here in a minute. Ignore that. What letter goes here? And ignore that. What letter goes there? Here. Here. J. K. What letter goes here? L. And they also told us this. Let's do this. Let's see. Ink color. Come on, give me a different color. I think they told us they put a little box in here, didn't they?
Yeah.
Anybody know what that little box means?
That's a
Right.
It's right angle. It's 90 degrees. So that whole thing right there is 90 degrees. That's what that little box tells you. Not sure why they put that little box on there, and then in the notes next time, guess what they give you the definition of. That little box. That makes a lot of sense. I didn't realize they put it on. They tell us in the figure, ray LF and ray LK are opposite rays. So LF, LK are opposite rays. So what do we know about this whole thing right here? 180, good. 180, ray LG, that's right here, bisects angle FLH. So that angle right there is being bisected. What's that tell us about these two angles? They're the same, they're congruent. So let's mark them as congruent, maybe put something like that in them so that we know that those are both the same. Now the next part, they say this. Watch closely on this so you make sure you understand. F, L, G. This is red. Measure of angle FLG. What do they tell us about the measure of angle FLG?
It's the same as
We know it's the same. What else did they tell us about it?
it equals 14x plus 5.
Good. And they tell us HLG, that's this angle.
That equals
I'm going to use
17.
my little straight line there.
That equals 17x minus
17x minus 1. Now you just told me a second ago, what'd you know about those two angles?
1. They're the same.
They're equal, right? It was being bisected, so they're equal. So what equation can I set up?
2x plus 5 equals 17x minus 1.
I know Fletcher got that. Liar. Explain to him again. What do we know about these two angles?
They're the same.
They're the same. They're congruent. So what should be true about those two expressions?
X equals the same.
They should be the same. Can we solve that?
Yeah.
How are we going to start to solve it?
Subtract 14.
These 14x's cancel out. You're left with 5 on that side.
3x minus
2
Now what?
Minus 1.
plus 1 plus 1.
Plus 1 on both sides. You end up with 6.
6 and 3, which would equal 2. Someone's at the door.
I see. Divide. So what's x equal? 2.
Yeah.
What did they ask us to find? Did they ask us to find x?
Angle, measure of angle FLH, which is both combined.
FLH. So we want to find the measure of angle FL. Ignore that. That's an LH. FLH. You're right, so it's two together, isn't it? So what are we gonna have to do? How are we gonna find that whole angle?
Plug in X.
Where at?
Both of them.
Both of them? So what's, like, use your calculator, what's 14 times 2 plus 5?
Okay, it's 28 plus 5.
33?
Yep.
So that angle's 33. Do we really need to plug into the other angle? What should be true about them?
It's the same.
Should be the same, so that angle's 33. They didn't ask us to find either one of those two angles, what they asked us to
We
find?
find FLH, which is both.
This whole thing, right? So how much is it?
66.
Oh, I put my box in the wrong spot, didn't I? Didn't you guys tell me that?
What are you talking about?
That's
The
right.
right ankle box?
That right there is the right angle, isn't it?
Yeah. It's in between. It's HLJ.
It's HLJ. I put it all the way down. So what do we know about this angle right here?
Where?
90 degrees. This is 33, that's 33, that's 90. Could we find this angle right here? Ignore that. Could we find this angle right here? From here to here? What should be true about all those angles together? They should add up to 180, so we should be able to go back and find that. They didn't ask us to do that, so.
It's 90.
Number 6. Can we do this without me drawing that whole picture and doing it over and over again?
You go first.
Angle EBH. Does everybody see angle EBH? Yes, no, maybe?
Yes. I always thought it was ABE. That's why I was like.
Oh, I'm sorry, I am on the wrong one. I'm gonna look at number 7. ABE. ABE. It's 2n plus 7. You could write that in there if you wanted. Measure of angle EBF is 4n minus 13. What do we know about those two angles? What do they tell us in the picture there? They're congruent to each other. See the little markings in the corners? Telling you that they're the same. So what equation can I set up?
2n plus 7 equals 4n minus 13.
How are we gonna solve that?
Subtract 2
Minus
minus.
2n.
So you're left with 7 equals 4x minus 13.
That should have been an n, shouldn't it?
And you plus 13.
What's 4n minus 2n?
2n.
2n.
Now what? Thought I heard it. Plus 13, right? 7 plus 13. Damon would have to take his shoes off so he could add it up. You don't? It's 20. 2n. Now what?
You divide and it gives you.
10.
Yep.
Should have read the problem probably. In the figure and then opposite rays bisects that.
Find ABE.
And it says find the measure of angle ABE. ABE. That's just that little part, isn't it? So what do we have to do?
How does it go to? Or divided by 2?
We're gonna plug in right here, aren't we?
Yeah.
So what's in?
10.
2 times 10 plus 7?
27.
27. That's the angle they were looking for this time. What's the measure of angle FBE?
27.
27 also. What's the measure of angle ABF?
40.
ABF. What would we do?
27 plus 27.
27 plus 27, right?
54.
Teachers, pardon the interruption for a late afternoon announcement. First off, boys golf in Talawanda has been canceled, and boys and girls golf practice for tonight is also canceled. Sophomore rock painting after school has been canceled due to the rain, and sophomores, you need to get your money in for your t-shirts. With that, remember, each of you are a piece of the puzzle. Takes all of us to complete that puzzle. Have a great Laser Monday.
I'll tell you what, we didn't get those other 4 or 5 done there. You can mark that off, write that down, that's your assignment, finish. add that to the problems that you got there.